A very warm welcome to this year's exhibition. We, the first year students of KLETECH, are proud to present our project, which we carried out as a part of Engineering Exploration course. We have titled our project as SWARAANK, which means musical notes. Yes, this is an interactive toy which plays musical notes. I am Mayuri Kalmat and I belong to Team 4. My other team members are Manoj, Pratik, Bhumika, and Ritin Kumar. We followed 5 steps of engineering design process to convert the need into a prototype. The 5 steps are problem definition, conceptual design, product architecture, detailed design, and design communication. At the first stage, during the problem definition phase, we formulated objectives, constraints, and functions which are shown as in here. This is the problem definition that helped us in the formulation of our interactive toy. The objectives are shown in red, the functions in blue, and the constraints in green.
These are the 5 generated concepts by our 5 team members. Here this is the final selected concept and this is the best concept because it consists of all the necessities that we had planned and also it consists of all the requirements.
Now let us switch to modeling and simulation phase. In order to build our interactive toy, we require different parts. So we first built all these parts in the Autodesk platform and then assembled the same. So here is the wheel base, clamp, car body, ultrasonic sensor and the push button. Here is the assembled final model of our interactive toy.
Hello all, this is the 3D simulation part of our interactive toy. Basically, our toy has an on and off button. So, when we press it down, the gear motors get turned on. It starts moving in a direction until it senses any obstacles. When being sensed by an obstacle, it blinks a LED to alert the user and also changes its direction in the opposite or stops moving. The ultrasonic sensor is responsible for sensing the obstacle. Our toy moves with the help of wheels. When we press the buttons on a toy, it plays music notes in order. Our toy has a specialty of reversing itself in the same speed once it senses an obstacle. The rotation of wheels takes place like this when car starts moving.
Hello all, this is the circuit of entire system developed on the Tinkercad platform. This is the integrated circuit of the system that contains the circuits of subunits like sensing, locomotion and music playing. So here as you see, we have made use of components like Arduino UNO R3, motor driver, 9-volt battery, US sensor, potentiometer, slide switch, resistor, LED, a piezo buzzer, 4 gear motors and 8 push buttons. Our toy basically has an on-off button, which when pressed on, primarily our 4 gear motors get on and all the components get active or you can just say ready to function. As we know that our toy has an exclusive characteristic of sensing an obstacle, it either changes its direction or stops as it senses obstacle within the range of 50 centimeter vicinity. It also has a unique feature of moving backwards with the same speed as it was moving frontwards. In addition to that, our toy has a feature of alerting the user by blinking an LED when sensed by an obstacle. It also has a feature of playing music notes when we press any particular button. So here we see it on the circuit practically. Let me simulate it. Yeah, so here when I slide the switch on, you can just see that all the 4 gear motors move with the same speed. And when the obstacle is being sensed, the LED gets on, which means it alerts the user. So I can just press the buttons and make the music play. So the code goes like this. Thank you. We all needed some place to store our data. So we used the GitHub software and hence created wiki pages for the same as suggested by our guide. So here are the pages. In virtual implementation phase of the course, we have stored our 3D models as shown here. And also the bill of materials, circuits of subunits as well as the integrated circuit of the entire system, the flowchart of subunits along with the entire system, and the motor sizing and battery sizing as shown in the video.
Here we are finally at the end of our presentation. We have learned many things from this project like how to use different softwares like Tinkercad, Autodesk Inventor, and how to document the project systematically. We also learned many mechanisms like slider crank, 4-bar, crack rocker mechanism. And we also learned time management, learned the usage of many devices like Arduino, breadboard, IR sensor, 2-channel relay. And lastly, I would like to thank our guide Kaushik sir for his constant guidance and support. Thank you.